Chapter 7.5. Today we're going to learn how to rewrite expressions involving radicals and rational exponents. Example 1. We want to find the cube root of 125. This is done, you can do it in two different ways. The cube root of 125 is the same thing as 5 times 5 times 5. So the cube root of 125 is going to be 5. You can also do it with rational exponents, and you can put it in your calculator if you want to. Okay, the fourth root of 16, that's going to be 2 times 2 times 2 times 2, so the fourth root of 16 is 2. All right, you guys work on your guided practice A, B, C, and D, and I'll give you the answers in just a second. All right, the answer to A is going to be 3. The answer to B is 2, the answer to C is 4, and the answer to D is 6. Let's pop up here to this box where it asks you to give an example of a radical. That's your example, and label each part. That part is going to be your index. That A is going to be your radicand, and the square root symbol is called a radical because it's not always a square root. Sometimes it is a fourth root, fifth root, or so on, like we've been practicing in example 1. Okay, key concept: equivalence of radicals and rational expressions. So pretty much what this key concept means is that if you've got a to the 1/nth power, that's the same thing as the n root of a. Also, if you have a to the mn power, that's going to be the same thing as the nth root of a to the nth power, or you can also write that as the nth root of a all to the m power. And that's going to be your key concept. So we're going to use that little formula to do all of our problems below. So example 2, 12a to the 2/3 power, they want you to write that in radical form. So the first thing you need to notice is that the 2/3 power is only applied to the a, so that's going to be 12. And then the 2/3 power, if you'll go back to your key concept, that's like mn. So the top goes for your exponent. The top goes for your exponent, and the bottom is your index. So we're going to do the same thing for our problem. Our a goes under the radical, our top is our exponent, and our bottom is our index. And that's going to be our final answer. We're not actually doing anything with it, we're just rewriting it and putting it in a different form. All right, example 2b. 64a to the 4/5 power. Everything gets the 4/5 power. If you have a scientific calculator that will simplify this for you, I suggest you do that. Otherwise, we're just going to take it a step at a time, and we're going to put 64a underneath the radical. The fifth root is going to be our index, and it's going to be to the 4th power because the top number of your exponent is your power and your bottom number is your index. And now we're going to simplify the 64 to the 5th power. Now there's not a number that you can multiply by itself. There's not a whole number that you can multiply by itself 5 times to get 64. But if you do 2 to the 5th power, you do get 32. And 32 times 2 is 64. So we're going to rewrite that as the 5th root of 32 and 2a to the 4th power. And I just told you that the 5th root of 32 is 2. We're going to bring it out front. We're going to leave the 5th root of 2a underneath. And everything is still to the 4th power. And then everything inside the parentheses gets the exponent. So that's going to be 2 to the 4th power and the 5th root of 2a to the 4th power, which is 16, and the 5th root of a to the 4th power. Okay, guided practice number 2. I'll write the questions for you. You should already have them, but go ahead and pause it and work on it on your own, and I'll give you the answers in just a second. Okay, this one is going to be the 6th root of a to the 5th, because the top number is your exponent and your bottom number is your index. B is going to be 5, and then the 3rd root of x to the 1st, or just x, because the exponent did not belong to the 5, because it wasn't in parentheses. And then C, we got to figure out a number. Let's just rewrite it. It's going to be the cube root of 54y, all squared. We got to figure out a number that can multiply by itself 3 times to give me 54. And there's not a whole number that will do that, but 27 does have a whole number that'll do it. Cube root of 27 is 3, and you can multiply 27 by 2 and get 54. So we're going to rewrite it like that. Then we're going to take the cube root of 27, which is 3. Then we got to square the whole thing, and we get 9 cube root of 2y squared. You could actually even simplify that further and square the stuff underneath the radical and make it 4y squared underneath the radical. That's a simpler answer. Okay, example 3, converting to exponential form. So now we want to go backwards from what we just did. Your top number was your exponent and your bottom number is your index. So my top number is my exponent. So I make that exponent the top number, and my bottom number is the index. So I make my bottom number the number we have for the index, and that's my answer. Okay, B. If you'll notice on this one, the 27D is not in parentheses, which means that the 5 only belongs to the D. So when I do this, that's going to be 27 to the 1/3, and then D to the 5/3. And you can simplify 27 to the 1/3, it's 3, and then D to the 5/3. Guided practice number 3, go ahead and start working on that, and I'll give you the answers in just a second. If you get stuck, you can always come back and I'll show you how to do it. All right, A is going to be S to the 2/3. B is going to be 12x to the 4/3. C is going to be 4y in parentheses, 5/2, because that's understood to be a 2. And then D is going to be 256 to the 1/4, A to the 8/4. And the 4th root of 256 is 4. And A to the 8/4 is really just A squared. Okay, example 4, we're going to use these radical expressions to do a biology problem. It says you can estimate the metabolic rate of a living organism based on body mass using Kleber's law. The formula, R equals 73.3, and then the 4th root of m cubed relates metabolic rate measured in calories per day to body mass measured in kilograms. What is the metabolic rate of a dog with a body mass of 18 kilograms? So you're going to take your formula, And they're talking about the body mass of a dog. So we're going to plug in 18. And then you just simplify it. And when you do all your calculator work, you end up with 640.6, or even more simple, 641 calories per day. Guided practice 4, you're going to do the same thing, except you're going to use a man with a body mass of 75 kilograms. So you're going to plug in 75 there. Do your calculator work, and I'll give you the answer in just a second. Okay, you get about 1,868 calories per day. Down here where it says tonight's homework, you don't have that on your paper. It's because you're doing your homework now. So we're not doing that. All right, bring any questions you've got tomorrow to class. Make sure you have this so I can grade it, and I will see you tomorrow.